Go.
Okay, what we have here is the input drum on the 401TE, and the design innovation that they incorporated here is pretty unique. Again, this unit was introduced in 1989, and it is the first and only unit I've seen with a bidirectional piston. And if we take an air check, we'll notice that the outer piston here will move up, and that's applying the reverse clutch. And when we hit the other port, it moves down, applying the overdrive clutch pack. Again, bidirectional piston, introduced in 1989, the first and only I've ever seen. And that is one of the unique characteristics of the 401TE. On the downside is that they had some integrity issues with the snap rings inside the assembly, which they had increased in thickness over the years, which have reduced the failure rate dramatically. So anyway, again, bidirectional piston, utilizing the reverse clutch and overdrive clutch with the single piston. So now we'll disassemble this, starting with the reverse clutch pressure plate. Snap ring. Pressure plate comes up next, and it's somewhat of a tight fit. That's why I'm using a screwdriver to remove it. Being careful not to gouge the plate. Utilizing one steel and two clutches for the reverse clutch. Again, this clutch is only engaged, this clutch pack is only engaged in reverse gear. So again, two clutches, one steel pressure plate. Moving on, we have a couple of thrust washers. We are moving on to the overdrive pressure plate and snap ring assembly. And as you can see, the snap ring is very thin. And the overdrive hub is indexed so that it prevents the overdrive clutches prevent the hub during assembly. And this is generally the most common failure area on the unit is the overdrive clutches. And this particular unit, they're not in too bad a condition. They are slightly burnt. I've seen far worse. Three stills, four clutches. Another washer, overdrive hub, underdrive hub. Below the overdrive clutches are the underdrive clutches. Underdrive clutches are energized in first, second, and third. Overdrive clutches are energized third and fourth. And this snap ring I'm removing now is the most common snap ring to break. But it's not broken on this unit. It does have the updated design, thicker snap ring, and recessed pressure plate to accept the thicker snap ring. Again, using the L end of the pick to help find the opening of the snap ring. Again, the Ray Charles method. Underdrive clutches, same count, 4 clutches, except it has 4 stills instead of 3 like the overdrive. The friction and the stills are interchangeable, same dimensions, same material. On some of the other units, they did change the high energy content, and they were utilizing the underdrive and overdrive and reverse as well. Next, we're going to check the integrity of the input shaft bushing, which feels pretty good. There's another common area of wear, and there is a snap ring that requires a little bit of effort to get out. And I found that 350 snap ring pliers work quite well for this. It's a little nasty guy. And then we can press out the input shaft. Okay, so the rest of the drum disassembly was going to require a foot press and a press. So we'll move on to the valve body. The valve body here, minus the solenoid block, which bolts on the exterior of the transmission case. The valve body regulates the fluid pressure going into the solenoid block. Solenoid block changes the pressure routing with a different clutch pack application. This rubber seal here is so that when the valve body is bolted to the case, it makes a good seal to the transmission case. We have another seal here they refer to as a multi-lip seal. This prevents fluid leakage from this switch here, which is the Prindle or manual lever position sensor, depending on which manufacturer you talk to. So now we're going to start to unbolt this, and in order to do so, we're going to need a separate basket for the part, because there's quite a few screws that will be coming off and disassemble this. Again, these are all 25 ports. And right now I'm removing the retainer for the 1-2 accumulator. Or excuse me. Yeah, this is second 2-4, if I'm not mistaken, accumulator. And now we're going to remove the neutral safety switch or the Prindle, whichever manufacturer you talk to. There is a rubber seal up here that I generally don't mess with because the fact that the fluid never gets to this point to leak out. So the switch will not go beyond that. I can wash it in the machine because it is just metal contacts on the plate, so there's no issue with water contamination. I remove the manual valve. The valve body, as you can see, there's multiple screws. The reason for so many screws is because of the warpage potential on the valve body. Now, I don't know of any issues on the 4.1TEs as far as warpage, but I know on the later models like Price and Riddle, the 45 RFE, 68 RFE, and so forth, they had issues with warpage. But as far as I know, the 4.1TE is not having that difficulty. So I would have heard about that by now. And again, as you can see, there's numerous screws. So I'll try to keep some order and removing them. They're all the same length. They're all interchangeable. There's just quite a few of them. Casting on here indicates that this is a 97. We'll check the paperwork later. There are casting numbers on the valve body indicating the year, so I'm going to go with it being a 97. Again, this unit was introduced in 1989. It had some revised changes, engineer changes, but overall, basically the same thing since 1989. So that goes to show you how unique the design was. Depending on the year of the valve body, they run a different number of check ball locations, or a number of check balls. This particular one should only utilize 3. 1, 2, and 3. Locations are fairly common, not a very dramatic issue. But what is there are some valves that are not loaded, meaning the retainers can fall out. So we got to remove them now so we don't lose them in the wash. Same with the valves. And if I'm not mistaken, this is a solenoid switch valve. I'm trying to dig out of there. Drain. Separator plate, 1 filter, it has a bimetal gate that opens and closes due to temperature. Check valve, spring loaded with an O-ring. And that is pretty much it on the valve body. We washed it in the machine, clear out all the material, double check the integrity and functionality of the valve, making sure that we have a free movement, and then we reassemble. We replace the check valves with new ones, and everything is good to go after that, including the filter is replaced as well. And that's a cut, and we're done.